So thank you everyone for joining me to listen to my 8 commandments on maintainable test automation. This talk is inspired by test automation efforts that started with much enthusiasm, but failed hopelessly, because after some time, it costs more time to maintain the tests than to do anything else. And according to the World Quality Report, maintainability, hello? Now it's no longer working. Of course it's no longer working. Let's try that again. Yay! So, according to the World Quality Report, maintainability is the most important issue when it comes to test automation. For those of you who are not familiar with the World Quality Report, go to worldqualityreport.com and you'll find this report that comes out yearly, where they do an analysis among, I think, 1,750 companies worldwide. So I'm wondering at this point, are there any people who have experience in test automation efforts with low maintainability? Show of hands. Quite a few. I'm not sure if that's a good sign or not. So before we dive into this any further, allow me to introduce myself. My name is Mazin, and I was born and raised in the Maldives. For those of you who don't know where that is, it's somewhere there in the middle of the ocean. You can't see it on the map. When I was 13, I moved to the Netherlands, and I learned Dutch, but what actually happened there was, in high school, I discovered programming on the graphical calculator. Do you have that in Estonia as well, the graphical calculator? Yeah? You do? Anyone did any programming on that? No? I was a nerd, I guess, so yeah. So this is actually where my passion for automation began. I didn't know it at that time. I mean, I was a young kid. I was like, yeah, just having fun. So not knowing that I actually wanted to do automation, I went and studied something entirely different. I studied aerospace engineering, but spent most of my university years making a lot of music. But luckily, I found my way back to automation, and I started working at Capgemini as a test automation engineer. And since then, I've set up test automation for several projects, and I'm now also a trainer at the Capgemini Academy, giving courses on test automation. So, why this talk? A while back, I was talking to a colleague of mine, and we talked about our experiences in test automation. And we realized that we'd both worked on test automation efforts which were quite successful, but also on test automation efforts that were not that successful. So we decided to compare these. And today I want to share with you my experience on how to set up a maintainable test automation project that will survive the years. So let's dive into that. This talk is divided into 3 sections. First, I will talk about some of the common issues that I identified in the field projects. Then I will talk to you about some of the basics of a test automation architecture. In my opinion, this forms the basis for success. And finally, I'll share with you my recommendations. So these are recommendations, not commandments, something you have to do. So I thought the wordplay of commandments was funny. That's why 8 commandments. So let's dive into it. I'm going to talk about some of the issues that I identified. And I'm curious whether you recognize these issues. And I'm sure that you've seen a lot of other issues out there as well. There are loads of issues out there with test automation. But today, I want to focus on 5 issues. So let's start with them. The first one is when keyword-driven steps have been improperly implemented, where, for example, every single action on the browser is described at the gherkin level. Now, the argument given here is that we have very reusable steps. I mean, I just create one step and I can use them everywhere. Yeah, great, until something changes in your application. That means you have to go to every single test where that step is used and change every single test. So that leads to a lot of refactoring. And it also leads to expansive scenarios consisting of a lot of gherkin steps, where it's unclear what the point of your test is. I've actually had a project where we had scenarios consisting of more than 140 steps. Good luck figuring out what's being tested there. No idea. So that was where frustration started for me. And quite often, you see that in these expansive scenarios that multiple functionalities are being tested in one single scenario. You actually want to have each functionality tested in its own separate scenario. But what you also want to prevent is that you create dependencies between your scenarios. So from going from one big scenario to small scenarios, you also don't want each scenario to be dependent on other scenarios, right? So imagine that you have one test that manipulates your system under test. And your second test depends on these changes from your first test. Now, if your first test fails, your second test is going to fail automatically. It doesn't mean that your functionality is broken. It just means that the preconditions aren't met. So you're getting the wrong feedback from your tests, which is something you want to avoid, of course. Next, I've also seen efforts fail where test frameworks became so complex that nobody really understood them anymore. And these frameworks were set up by developers with all good intentions to be future-proof. So this might be a cool functionality. Let's add it in. Or this looks cool. I'm going to add that too. But there was no requirement for it. So what you're left with is a framework that the people using it don't understand. They don't even know which functionalities are all in there, so it's bloated. But the worst part is, at some point, nobody dares to change it anymore. They don't really know what's going on there. So imagine what happens when the person that actually built up that framework leaves, is that they say, yeah, nobody really knows what's going on here, so throw it out the door. We're going to start from scratch again. That's not maintainable. And finally, I've also seen test automation efforts fail where only one person was responsible for the automation. Now, this person was an expert. He or she knew everything about test automation, but he or she was also the only person actually adding tests and actually looking at the results. That doesn't work. Imagine what happens when that person leaves, right? So these are the 5 issues that I wanted to discuss with you today. And like I said, I'm sure that you have seen many other issues out there as well. But let's first dive into how can we avoid these issues? How can we solve them? And that starts with, so 5 issues. That starts with with setting up a proper architecture, a proper test automation architecture. And I want to talk to you about creating different layers of abstraction, where each layer has its own responsibilities. Now, the first layer is obviously your system under test. This might not be a layer that you as a tester will be working on actively. But in order to test something, you need to understand it. What is it that I'm actually testing? Is it a website? Do I have API services? What is it? Your next layer is your test framework. Your test framework allows communication with and manipulates your system under test. So if you have a website, you might have some kind of web driver. If you have services, you might have some kind of API library, right? By no means does your test framework contain anything that looks remotely like a test for your system under test. It only facilitates, it only shows you what you can do with your system under test. It doesn't actually test it. Now, the next 2 layers are your test specification and your test implementation. Your test specification focuses on what? What is it that I'm testing? So, what do I need for my test? What is the actual action that I'm doing? And what is my expected result? And this can be done using Gherkin, for example. And each of these steps in your test specification layer are then, of course, implemented in your test implementation layer. And here you focus on the how. So how do I prepare for my test? How do I perform my actions? And how do I verify that it's actually successful? So this will include your step files, your helpers. If you're using the page object model, it will be your page objects are there as well. Your test implementation uses your test framework to communicate with your system under test. That's how that works. Now, a test implementation layer can use a test data layer to provide the actual test data that you're using for your test. And this can be hard-coded data or generated data, depending on your needs. I'll come back to that later. And the final layer is your test reporting layer. This layer generates a meaningful report that helps you locate issues whenever a test fails. It uses input from all the other layers to do that. Now, as a tester, your day-to-day work will be focused on the left side of this spectrum. And this I call the create side of these abstraction layers. Here you'll add new tests, refactor the existing ones, clean up tests, right? This is your day-to-day work. The other side I call the use side. This side will take some time to set up initially, but should only change if something in your system under tests changes that actually requires your test framework to change. So this will be more static. It won't change as often. This might sound quite abstract, so let's look into a more detailed example of this. So how can we implement this, for example, using the tools that we are using in our day-to-day work? So if we look at the test specification, you can do that using the feature files. So I'm talking about the given when-then scenarios that we write down in our feature files, and preferably in a business-oriented language, right? So that everyone understands what's going on there. You get a new tester in, he understands what the purpose is of what we're trying to do there. Your next layer is then, of course, your test implementation, and I'm going to split that up into two separate layers. So each step in your feature file will, of course, be implemented in your steps file. And your steps file can have a functional implementation. And what do I mean with functional implementation? That it won't have any programming logic in there. Your steps file will be readable like a test script. So it will use methods such as login as admin, fill in the form, and verify message. These are functionally readable methods that everyone can follow. Now these functions are then implemented in your technical implementation layer. These are your helpers or your page objects, right? There you will have your coding language, your if statements, your selectors, everything like that. This technical implementation uses methods such as getWebDriver, findElement, or waitForit, that are then, of course, in turn provided by your test framework. And your test framework is responsible for WebDriver management, for browser resolution, stuff like that. In this case, it will contain something like a Selenium WebDriver, since it's a website that I'm trying to test. And of course, you then have your system under test, which is the website. Now, I'll go into some more details on the test specification and test implementation layer in my 8 commandments. But before I do that, just a small note. This isn't the perfect architecture. I don't believe in the one architecture to rule them all. So look at your context. Based on your context, it might not be necessary to split up the test implementation into 2 different files, for example. If it's a single microservice that you're testing, you can do that in one file, right? But the point is, you want to have these test specification, test implementation, and framework and system under test separately. So even if you do it in one file, add code commenting or whatever, so that you make clear what's happening, right? So before I go into the 8 commandments, Marcus just gave a nice presentation about the gherkin that he replaced. I want to quickly go back to the basics of gherkin, so that we're on the same page before we move on. So as you all probably know, gherkin is all about given, when, and the then, right? So given is where we prepare what is the baseline, what are the preconditions that I need for my test. The when is the actual test that I'm performing. So ask yourself, what is it that I'm testing? And of course, the then is your expected result. Now, with that in mind, let's move on to the final section, the recommendations, the commandments. And a small disclaimer here before I dive into these. I believe that these recommendations that I'm about to give you can help you in your day-to-day work. However, by no means are these recommendations law. There are no such thing as best practices, only good practices within a certain context. So adapt these recommendations to your needs. right? All right, the first commandment, it actually corresponds to the first issue that I showed you. So here we see these expansive scenarios where the selectors are defined at the gherkin level. Like I said, if something changes in your application, you need to go into every single test and update those. But what I found most annoying about these scenarios was actually that I had no clue what we were trying to test here. I'm seeing all these actions happening, but what's the goal? Which is why commandment number 1 says that a typical scenario should be 3 to 5 keywords long. So if you analyze this scenario, you realize that what we're trying to do in the entire first part is actually filling in a contact form. And I hope you all agree with me that we can write this in a much more readable way. And even the last step can be written in such a way that we understand the value of that step. What am I trying to achieve here? So now we're left with a much more compact and readable scenario. If we zoom in on that scenario, we actually realize that we're assuming that there's already a page with a contact form on it. But in most cases, your content will not be the same throughout your dev, test, ACC environments, right? They'll be different. And in most cases, if you run one test, it might even change what your context is. So we need to make sure that our test can run independently, and that it doesn't depend on another test that first creates that content and makes it ready for us. So, which is why commandment number 2 says that a single test should be responsible for managing its own test data. So in order to run this scenario independently of all the other scenarios that I have, or independently of which environment that I want to run it on, I actually capture my precondition in my given. So given a content document, the contact form, that step will allow me to actually create the content document and make sure that my test data is there. Now I recommend doing this using something like an API or a direct database connection, some means of injecting test data in a quick manner. Not using the UI to actually do this. If you don't know how to do this on your project, talk to your developers. I'm sure they'll be more than happy to help. All right, so you're probably wondering, great, if I need to manage my own test data, but how do I actually implement that? Well, let's dive into that. So let's zoom in on the second step here and see how we can actually implement this. So the functional implementation, like I said, is in the step files. In the step file, you see here, Cucumber with the Java method that corresponds to it, below it, right? So what I want to do here is have a functional implementation. In other words, my steps will look something like this. It is readable as a test script for everyone. So on the vacancy detail page, I'm opening the vacancy form. On the vacancy form page, I'm filling in the data. And on the vacancy form page, I'm then submitting it. Everyone can follow this. I don't need to be able to code or read code or write code to do this. For those of you who are interested in the technical implementation, I'll just show a quick setup of how you can do this on the technical level. For those of you who don't like coding and Java that much, bear with me for a few seconds. I'll keep it short. So on the technical implementation, I'll have the pages, and in this case, it will be, for example, the vacancy form page. The page has knowledge of your selectors. So it has the information of the elements that are on that page. And it also contains the methods that I'm actually using in my step files. So for example, that fill data method would be implemented on my page object. I don't want to dive into more technical detail on this part. What I actually want to focus on is the form data, because I'm passing in that form data to my page object to fill in that page. But at this moment in time, I still don't have any actual test data. So I need to get that data in some manner. And there are multiple ways to do this. I've seen projects where large Excel files were read in. I've seen projects where the data was hard-coded on the pages. I've seen projects where the data was all summed up on the gherkin level. You can do all these different things. But my recommendation is actually to manage your test data as code. How I would do that here is I create a class that actually creates my test data for me. And that's then used to fill in the form data. And this class can generate random data, or it can generate default data, depending on your needs. Now this allows you to have data that is always in sync with your test, right? You don't have any versioning problems anymore. You don't have any external dependencies because you're not reading it from an external thing anymore. So this gives you all those benefits in there as well. But I can hear you thinking, great, but what if I need specific data for one test and other specific data for another test? No problem. We can do that as well. Like I said, I don't think it's a good idea to clutter your gherkin level with all the data that you need for a test. But there might be specific driving data that is important for your test. So most scenarios you have like a lot of random data that you can just fill in without really worrying about it. But there are 2 or 3 data points that actually change your test result or that are important for your test result, right? So that's why commandment number 4 says only control your relevant test data and generate everything else. Don't worry about all these names or addresses or whatever that, that's not interesting for your test case because they don't do anything with the logic. But only control what's actually relevant and important for this specific test. So if I change my step a little bit, I now know that these 2 data points are important. If for some reason I have to reproduce this test manually, I know that I need to focus on these 2 data points, that they need to have these certain values. Now, if you look at the functional implementation, it doesn't change that much. What we're seeing here is that we're actually passing on that data now, that same class that I had before, we're passing it on from our gherkin level. And it's not only these 2 fields that are filled, these 2 fields are filled with the value on the gherkin level, and all the other fields are filled with generated default or random data. Now, the rest of your functional implementation stays exactly the same. You don't have to do anything else. If you're interested in how this works with Cucumber and everything, I am working on a blog at this moment and explaining with code examples how to do this with different versions of Cucumber. It's not ready yet. If you're interested in that, follow me on LinkedIn or Twitter. I'll make sure that I post it there as soon as I'm done. What I want to do now is actually go back to some of the recommendations on the test specification layer. Because, like I said, we had these scenarios where multiple functionalities are tested in a single scenario. Imagine what happens if the test fails in the first part of your scenario. You get 0 feedback on your second functionality. So you go in, hey, the test is failed, let's fix it. Maybe it's a test fix, or maybe it's the code fix that needs to happen. You do that work, and then it's finished. Cool, you deploy that and you run it again, and then you realize, hey, shit, the second functionality is also failing. That costs you an extra iteration to get that feedback. You don't want that. You want to get that feedback as fast as possible. Which is why commandment number 5 says that a single scenario should describe a single test. So if we look at this example here, we can split it up into a scenario where we add an item to a shopping cart and into a separate scenario where we're actually removing the item from the shopping cart. 2 different functionalities. So split those functionalities up as well in your scenarios. You also don't want to have multiple instances of the exact same test just because you want to run it on a different browser or a different size or whatever. Your test specification should not dictate on what platform your test is run. Your test specification is only responsible for determining your given, when, then. What is it that I'm testing? If you want control over your browsers or your resolution sizes, whatever, use tags. And using tags means you can also now use a test runner that gives you control over these tags. But moreover, if you're now using a test runner, you can now easily integrate your test suite into your CI/CD pipeline, because you can now easily run it through a Maven command. And if you integrate it into a CI/CD pipeline, it means that you visualize your tests and that they execute very often. So every time your pipeline runs, your test runs, giving more focus on maintainability, because everyone will feel the pain once your test fails. If you only visualize fail or pass on your pipeline, then your teammates are still going to come to you and say, hey, it's failing. I don't know why. Can you look into it? Which is why commandment number 8 says that the test results should be easily accessible and give leads towards solving possible issues. So in my last project, we had the pipelines run the tests and immediately after that upload the test results, the reports, to a server where everyone had access to the results. Everyone in the team, the business and also developers and other testers, everyone could see what's the status of my tests. Are they good? Are they not good? And if they were failed tests, you get a detailed report telling you exactly in which step it failed and why it failed. The UI tests even included screenshots showing them the latest state of the website when it failed, when the user saw that it failed. Now, this helps shift the responsibility from one person to now your entire team. Because everyone can now go in and see, hey, what's happening? Where is it failing? Why is it failing? Oh, maybe now I can try and fix it. They no longer need to come to you alone, right? You don't have that single point of failure anymore. So those were the 8 recommendations, the 8 commandments. A typical scenario should be 3 to 5 keywords long. A single test should be responsible for managing its own test data. Manage your test data as code. Only control your relevant test data, generate everything else. A single scenario describes a single test. The test specification should not dictate on what platform the test will be run. Test suite should be easily integratable in the CI/CD pipeline, and the test results should be easily accessible and give leads towards solving possible issues. So, now that you've seen the common issues, the test automation, an example of a test automation architecture, and my 8 commandments, I hope that I've inspired you to go home after this conference and on Monday start work again and talk to your team. How maintainable are our tests? Can we improve the maintainability? Or maybe that you're looking forward to your next project where you can set it up with maintainability at its core. Thank you.
Thank you. Now we have time for questions. So please raise your hands.
I actually have a question.
Please.
Thank you for the talk, very relatable. You said that when only one person is responsible, it's not very good. So make the whole team responsible.
Exactly.
But I've had experience that when the whole team is responsible, no one is responsible. So how to tackle that?
So we're talking still about T-shaped teams, right? So you'll have your expertise in the fact that you might be the person that, or there might be another tester that's the person that's actually doing creating the tests. But if you involve the developers, if you involve them and show them the code as well, then they won't be coming to you every single time something fails. They will also feel the responsibility of saying, hey, this test is failing. Is it because my code is wrong or is it because the test is failing? And they can pick up that work as well. It doesn't mean that all the work will then come only to you. And yes, you have the fact that if everyone is responsible, nobody feels responsible. That's a much heard argument. But I think in agile teams, what we try to create is that the team is always responsible for the entire product, and that means including the tests as well. So that's what I would like to strive for, actually. Does that answer your question? Kind of. Yeah? Any others?
Yes, I see one hand.
Thank you. Great presentation. It's almost scary that our company went from our test to almost one to your presentation.
Okay.
Yeah, we had the same experience with the automatic tests. We had one person responsible, then company growth, then there were 12 testers pushing the tests inside. So we had to rebuild our solutions from the ground up. Yeah, but my question is, do you feel that if you're growing that big, because our team, our company is split in the teams, we are reusing partial of the part teams, we went to Constellation way of the sharing of page objects, yeah?
Mm-hmm.
Do you feel that even with these 8 recommendations, it will be growing, it will be more and more harder to scale outside at some moment?
Scalability is only will also be better if your tests are set up maintainably as well, right? So like I said, if your system under test changes and you would have to go through loads of tests to update those as well, that means that you'll lose a lot of time when your system grows. So if you set it up in such a way, in a maintainable way, even if it scales, if you use, for example, the page object model, what we talked about, there should be one representation of that page. If your system scales, you'll be adding more pages, and that's fine, because you still know exactly on which page something changed. So you still know exactly where to change that single thing, and everything works again. So for scalability, I believe this still works, yes. Yeah? See more hands there.
Eden here. I'm really curious, how many systems were being tested with that scenario of 100 and something
Yeah,
steps?
104, yeah. So that was one huge website. And the 140 steps, what they did was, you had a step for logging in, you had a step for clicking on create content, you had a step for click on this field and fill in that field. So you had like a content document that's already 30 fields long. So that's 30 steps already, right? And then you had a step to then go to a certain page on the website and then fill in the data, and all the data is filled in with, again, separate steps. And then you have a separate, in the same scenario, you go to the next page and then you say, okay, now I'm gonna do a separate fill it again in a second time. Same scenario. And then you have another thing that goes, okay, and now I submit it, and then I want to check that it's in the API, that the API call goes, and it's in the database. Everything was compiled into one single thing. And then also, also what they also did was, at the end, it wasn't finished yet, because then they went, okay, now I want to revoke it as well. So I sent the form and I want to revoke it, do it in the same scenario. I revoked it, and then I say, I want also the confirmation in the same scenario. Come on, that's different functionalities. Yeah. So the question there as well.
Great presentation. Didn't learn much because a lot of the commandments I have already followed.
Good.
Like evolutionally. But my question was regarding Gherkin and BDD, like the abstraction layer. What I've encountered is that when you have large web applications, at some point you have hundreds and hundreds of steps, multiple people working on those strings, step strings, and you end up having a mess because the naming patterns are different person to person. There's some duplication because if it's not only you writing, you don't know all of the steps that actually might pre-exist written by somebody else.
Yeah.
And my question is, have you encountered this problem, and how have you tackled it?
Yeah.
Thanks.
So in our current project, we work with SAFE. So we have a train, and we have multiple teams that are working on different projects. So what we have decided there is to split up our tests projects per value stream, we call it. So then you don't have these massive repositories for, for all the systems together, but we split them up into operational value streams, we call that, which gives you, instead of having hundreds and hundreds of steps, you have a smaller base where you won't run into that issue as often as you would have when everything is combined, yeah.
And the common parts are separate?
Yes, so the common parts, we put them in the library, and that library is then used by all of them, yeah.
Good point. Thank you.
Yeah, welcome. I see a hand over there. I actually don't know if there's any more time for questions. I'm just going.
Yeah, actually, this is the last question.
Thank you for your talk. My question is that let's say that we have as small tests as possible, which is like basics of test automation, right? But then business comes in because you have a complicated business process, right? And you need like let's say that you have these small tests when you fill out the form and your test ends there. But what about the business process?
Yeah, so I've had this conversation with the business many times as well. And what I've explained to them is, yes, from your perspective, your flow starts there and it ends after you've gone through all these functionalities. But that doesn't necessarily mean that all these functionalities should be in the same scenario. You can still show them that all these functionalities are tested and even have that order in there, but still have them in separate scenarios. So you can show then to the business, okay, so filling in that form, check this feature file. Validating that there's a message coming in or whatever, or revoking it, check this feature file. So you can show, I still show the business that all their functionalities are met and are covered in the combination of all the tests together. Does that help? She needs the microphone again.
But this is still like a system test level, right?
Yeah,
what about like acceptance?
Also on end-to-end test level. So on the end-to-end test level, I ran into this as well.
But you're not testing from end to end.
Yeah. So
you're testing it in sections.
Yeah. So one of the pitfalls that I see is that when you think about end-to-end testing, that you say we have to do everything in one single scenario. But if you validate your starting point and your end point, and you say, okay, the next point starts here, but we're doing it in a separate scenario, you can still have that end-to-end coverage without having to do it from beginning till end. The most critical business flows, so like in our project we have two very, very critical business flows. We said, okay, if this is that important for you, let's make an exclusion for this and we'll have a longer scenario. But still, we describe everything on a functional level, so our test is then 8 steps long instead of the 3 to 5. Yeah? I guess that was all the time we had for questions.
Yes, and now it's time for applause.
Thank you. Thanks.